Welcome to another Earth Science podcast. I'm your host, Mr. Buss. This podcast is going to be about climate change. It's important to understand that there's two different kinds of climate change, short-term and long-term. And normally when you think of climate change, you're thinking about long-term climate change. So let's first of all go ahead and talk about short-term climate change. In this example, we're going to talk about a normal year versus an El Nino year. Basically, in a normal year, you've got atmospheric circulation going on in a convective loop. Remember, warm air rises, and so as the sun heats the earth, the warm air is going to rise and it's going to go through atmospheric circulation. And the air is, in this case, blowing in the western direction off of South America. And what that's doing is it's pushing away the warm surface water, and it's allowing this cold current to come up. And that's important because that cold, deep water contains nutrients. And so those nutrients are brought up to the surface where there's sunlight, and that is the start of the food chain, right? So plankton are going to take in those nutrients, use the sunlight for energy, and that's going to help feed the fish population and the bird population and even, inevitably, the human population as we fish in that region. In an El Nino year, there is a disruption in the wind pattern, and so you have a little bit of a different atmospheric circulation pattern, and because of that, if you notice here, you don't have upwelling, and so that's actually going to disrupt the food chain, and you're going to have a low amount of fish, and there's going to be starvation, and also humans will not be able to get as much food from this region during an El Nino year. If you ever hear of a La Nina year, basically that's just a normal year with more extreme winds blowing across in the western direction, pushing, and you're getting more upwelling. So in the short term, oscillations between one event, like a normal year, to an El Nino year and a La Nina year, are going to change climate, but not for the long term. It's just going to go back and forth between these different types of years. All right, what about long-term climate change? So long-term climate change, just some general comments here to make. Climate has changed throughout Earth's history. This is not, even though if you hear, well, we're going through climate change, the Earth has been experiencing climate change throughout its 4.56 billion year history. Earth's climate is stable, and then it goes through change. It typically will be stabilized at a certain type of climate, and then it'll change to another type of climate, and Earth's climate is right now changing to another type of a climate. Why is that? Drastic and recent changes in greenhouse gas composition in the atmosphere are the reason for this current change. Much of the time the Earth's climate was hotter. Okay, so even though we're getting warmer, the Earth has seen warmer climates. It's just that humans, in our existence, in our 200,000 year existence, have never seen a hotter climate. We could probably survive it just fine. It's just that there are so many billions of people on the planet that have to cope with a changing climate, and that puts a lot of stress on the Earth and the resources we have available. Right now we're actually in an interglacial period. 10,000 years ago, your house might have been covered by a big block of ice called a glacier. Fairly small temperatures, differences in temperature can have major effects on climate. And changes in climate have had effects on human civilization. So this graph is kind of hard to read, but you can kind of follow a trend here, right? The reason there's red line, yellow line, green line, blue line is because each line is data obtained from a different source. So when you take all these and look at it, you kind of see the overall pattern here. So this is just kind of illustrating that in the last 2,000 years even, the climate has been changing. The medieval warm period allowed Vikings to colonize Greenland and Great Britain, and the Little Ice Age. From the 14th and 19th centuries, Vikings were forced out of Greenland, and humans had to plant crops further south. So human civilization is affected by climate change, and it doesn't take a lot in terms of the degree temperature difference. The average global temperature during glacial periods is only about 5.5 degrees Celsius less than the average temperature. So it really doesn't take major differences in temperature to put the Earth into a different type of a climate. It's also interesting to note that just little things like the reason the Little Ice Age occurred, that we believe the reason that it occurred is because there was a lack of sunspots on the sun during that time. So a lack of sunspots decreased the amount of solar energy coming into the planet, and it caused a little ice age. So little things can cause major changes in our climate. All right, so let's go through the list of causes of long-term climate change, and I just mentioned sunspots. All right, so sunspots are magnetic storms on the sun's surface that increase and decrease over, on average, an 11-year cycle. When the number of sunspots is high, solar radiation is also high. So sunspots are going to increase or decrease, depending on their presence, the amount of energy that the Earth is receiving. I should mention too that the sun's temperature has changed as the star has gone through its normal phases. In addition, our proximity or closeness to the sun has changed over our 4.5 billion year history. So those things have also changed our climate over Earth's history. All right, so plate tectonics also plays a huge role in the climate of the Earth. Now, this isn't something that we're going to have to deal with during our lifetimes because plate tectonics occurs so slowly, right? But when you had like a Pangea type Earth, you're going to have a different type of climate than if you have the continents broken up. If you have land masses at the poles, you have possibility for glaciers to form at the poles and so on. All right, now this one might seem minor, but again, little changes can have big effects on our climate. The Earth, as it rotates on its axis, is at a 23.5 degree tilt. That's not always the case. Sometimes it's at a little less, a 22 degree tilt, and sometimes it's a little greater, 24.5 degree tilt. So those minor differences in the tilt of the Earth as related to the sun can cause differences in climate. Do you remember when we did the lab where we taped a temperature probe to our globes and we got the temperature in Minnesota in the summer and in the winter? Imagine if the degree tilt were greater, it would get colder in the winter and warmer in the summer. So a greater tilt is going to make for more extreme winters in the north and south. So it can cause ice to really start to build up in the poles during during periods of time when there's a greater tilt. So the Cretaceous-Tertiary boundary in the geologic time scale in the rock record shows a line, a band throughout the planet that contains a lot of iridium, which is an element found in asteroids. So scientists have hypothesized and have a lot of evidence for an impact event. Impact events can drastically change climate as they obviously cause a lot of disruption on the planet. They're going to have a lot of immediate impact, a lot of extinction of animals and plant species in the vicinity and even planet-wide as global temperatures probably plummet because of all the debris that has been thrown up into the stratosphere, the upper levels of the atmosphere, causing solar radiation to not be able to get to the surface of the planet and causing a drastic cooling of the planet that animals and plants probably can't deal with because it might last for a little while. So long-term climate change can be stimulated by an impact event. So the dinosaurs didn't live through this one. I'll mention as well, another catastrophic event could be a supervolcano explosion, which happens periodically from time to time as well. And finally, last but not least, the composition of the planet's atmosphere. Earth's atmosphere has not been stable throughout Earth's history. Imagine it didn't have any oxygen in the atmosphere. Now we see about almost 21.5% of the atmosphere is oxygen. Well, that had to accumulate over time as oxygen in the oceans accumulated because of life in the oceans, and then that oxygen spread out to the atmosphere over billions of years. It took a ton of time to fill the Earth's air or atmosphere up with oxygen. Well, likewise, as we are recording increased levels of carbon dioxide, methane, nitrous oxides, ozone, other greenhouse gases, we are seeing a correlation between the composition of the atmosphere and an immediate increase in the temperature of the globe. Now, that doesn't mean that it's going to be hotter tomorrow because of this change in the atmosphere. But what it does mean is that globally, the Earth is going to reflect more heat back to the surface. The atmosphere is going to reflect more heat back to the surface of the planet. That's what greenhouse gases do. So if you increase the amount of greenhouse gas in the atmosphere, you're going to increase the reflection of heat back to the planet. And that'll end this podcast, so I'll see you next time.